Okay, let's do some integration by parts problems. Starting with, evaluate the integral of x squared cosine 3x. Don't go into these things like without thinking about them. Think about them. Here's the formula. You're going to pick a u and a dv. For the u or the v, whichever it works out for, you want one of these to eventually, as soon as possible, become a constant, so that this will not be another integration by parts problem. This will never become a constant. This will. It's going to take, you've got to find this, not the first derivative, but the second derivative before it becomes a constant. And that means you're going to be doing this integration by parts part twice. So be prepared for that. But your x squared is your best bet for your u because it becomes a constant after just a couple rounds. Okay, so I always like to have my formula up here so I can see it, so I can refer to it. Don't try to keep everything in your head. We're saying that our u is x squared. The derivative of u is 2x. If I forget those things, I've got this little table I've made for myself that has all sorts of handy things on it that you can download. It's in the notes. And now that means my dv is going to be cosine 3x. Integrating cosine 3x is sine 3x over 3. And again, I know that because I see something very much like that over here, and that helps me out. Okay, so let's get our problem set up. I get rid of that because it's going to confuse me. U. We'll have u is x squared times v sine 3x over 3 minus integration sign v sine 3x over 3 times du, which is 2x. Okay. I can clean this up a little bit by just pulling out the 2/3. Let's do that. X squared sine 3x over 3 minus 2/3. Put the x here. Sine 3x dx. I have the dx over here too. Make David Butler happy. Okay, so here we go. I've got another integration by parts problem right here. I expected that. So I have to start all over again with just this term to do this whole thing. So my u, being consistent with before, is now going to be x. My du is going to be 1. Yay, that's what I want. dv will be my other term. Sine 3x. So my v is going to be a negative cosine 3x over 3. Okay, I don't like when I see these negative signs because I'm going to be having to distribute negative signs and I get confused. But we'll be good. We'll be a superhero. We're going to get this done. Sine 3x over 3 minus 2/3 doing this whole thing over again now. To find the integration by parts of this is u times v, that's negative cosine 3x over 3 minus integral of v negative cosine 3x over 3 times du, which is 1. Yay, so I don't have to put it in. There we go. All of these negative signs to distribute are going to make me a little crazy. But the good thing is that I know there's a rule to integrate this term. Awesome. I don't always write out everything again. This is one of those situations where I don't. I'm going to just put a big cloud around this. And this tells me that this term, I can think of this term, negative cosine 3x over 3, I can think of that as, the integral of it is negative sine 3x over 9. That's it. These are equivalent things. Yes. So I'm close to the end. I'm going to have to be real careful about my negative signs. Let me just see what I can do right off the bat. X squared sine 3x over 3. What am I going to do? Okay, I'm going to note that there's 2 negative signs here, so that's going to become a positive. But when I distribute this negative sign is going to be distributed between this and this. So that's 3 negative signs. So this term is going to end up being a negative. So the first one, the negative will be a positive 2x cosine 3x over 9. Now negative makes negative. Negative 2 sine 3x over 27 plus c. Now I can stop here, or I can easily put this over all of them over 20. I can simplify this further and factor things out, but I think I'm going to stop here. This is a perfectly legitimate answer. If you want to do some more algebra to simplify that, be my guest. But there we go.